Okay, in this session, we are going to talk about the other method for error checking, and that is the CRC code. So let's continue with this example. If I ask my friend that when will you receive the number, it should be even number of ones. That is an example of parity bit. And the example in our everyday life of this CRC code is that, hey Lin, whenever you have received a number, it should be able to divide for example, we put a number there, maybe 12, like 7, and have the remainder of 0. Otherwise, that number may have problems during transmission. In this case, when Lin received a number, for example, the other day, Lin have received a number 15. What is she going to do to check whether the number is right? She will divide the 15 by 7 and examine the remainder. If it is 0, then she would think there's no problem. However, in this case, the remainder is 1. She will know the number has problems during transmission. Okay, it is still a little bit confusing when you see this example. We still do not know what is CRC code. Let's look at the PowerPoint. The CRC, the full name is cyclic redundancy checking, and it is considered as another method for error detection. To calculate this CRC, we need to learn modular 2 arithmetic first. Okay, what is modular 2 arithmetic? Modular 2 arithmetic works like clock arithmetic. In clock arithmetic, if we add 2 hours to 11, we actually have 13 as the result, but we consider that as 1 o'clock. In modular 2 arithmetic, we add 1 and 1, we get 0 as the result. So the addition rule becomes like this. 0 plus 1 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 0. For error detection and correction using the cyclic code, we need to learn this way for dividing. The dividing in modular 2 arithmetic is like this. We first write a number here, and then write the divider here. So we write the original number like this, and then the number to be divided being here. After that, we just continue add the result here, and then continue, if, for example, like this, the 0, 0, 1, 0, if we add another 1, then we still can have only 0 here, and then another 0, we can add some number. The result of this is the process of doing this calculation is put in this website. We use this number to divide 1101, and here is 1. Down here, we should have the remainder 1 and 0. Continuously, we write one number 1, and then here the result is 0. Another number 0, the result is 1. So we have 1101 here. Then we are going to calculate the result actually using modulo 2 subtraction, but it's pretty easy to understand. And actually in between all these steps, we are going to use modulo 2 arithmetic. So we get the result 0, 1, 1, 1 here. We are going to, the method that is performed here is modulo 2 subtraction. Okay, and we continue to do that until we calculate out the digit until the last digit. And as you can see, there is a remainder here. The remainder, we are going to put it here. I mean, it is when we finish adding the last digit here, the number that is down here. Okay, so before this slide, we were kind of talking about some basic modulo 2 arithmetic, including the adding, the dividing, and the subtraction. From slide 24, we start to talk about the CRC code, how to calculate the error detection in CRC code. For CRC code, we also need to calculate out the error detection bits. The error detection bits is calculated like this. So firstly, we want to add some zeros after the original number. And the number of zeros added should be 1 digit less than the divider. As here, we have 1101 as the divider. There are 4 digits in total. So we are going to add 3 digits after the original number, and that is going to be divided by the number here, 1101. Then we are going to do the dividing using modulo 2 arithmetic. Until the end, we have a remainder here. The remainder is 0111. Then we are going to add this remainder to the original number, and that is going to be the number to be set. In this whole process, we need to care about several issues, the names. So the error detection bits, which bits are considered as error detection bits? As the first question. The second question is, what is the number to be transmitted? And the third question is that when the receiver gets the number, what are they going to do? If no bits are lost or corrupted, dividing the received information string should get 0. And answer the third question, how the receiver check whether the value is correct or not. And then for the second question, what is the error correction bit? So we consider the last 3 digits which were added being the error detection CRC bits. And then for the first question, we haven't answered that yet. What is the number to be transmitted? I guess you know it already. It is the number like this with the error detection bits. There are 2 examples here. There is one example here which is very nice. If we are trying to transmit this value, and then we need to firstly in the information given, there should be one arbitrary binary pattern, which is the secret code between sender and receiver. In this case, it is 1011. And then we are going to add 3 zeros, considering here has 4 digits, to the original number. Then we are going to do modulo 2 division until we get the remainder 100, which are the CRC bits. So now we know the number to be sent is going to be the original number at the 100. And when the value is received, we want to use that value to divide the original secret code 1011 to see whether the remainder is 0. If it is, then we consider the transmission is correct. Okay, very nice. As we know, for error detection, we cover two methods, the parity bit and the CRC code. For error correction codes, there are other methods, such as the Hamming codes or Reed-Solomon codes. Those are something very important in computer network or communication. I guess in the future courses, if you choose computer network or communication as your future direction, you are going to know about them more. Thank you. I wish you have known something about CRC code, know something about error detection and correction.